In this video, we're going to go through 5 worked examples for titration calculations. You can download the slides from the website, and then you've got them as part of your notes. If you can have a go at doing them before the answers appear. So these are the first 2, so you can pause them to take a note of them and work them out if you like. Or I'd say download these pages. And questions 3, 4 and 5. Slightly different as we attempt each one, although 1 and 2 are quite similar, so if you do one with a bit of help, try number 2 by yourself. Okay, so let's get into the actual solutions. So here's question 1, just to remind us. So we've been told the equation, and we also have the concentration and volume of sulfuric acid. So the first thing we can do is work out our moles of sulfuric acid, remembering to always convert centimeters cubed into decimeters cubed by divided by 1,000. So concentration times that volume gives us 0.0005 moles. If we then look at the equation, 1 mole of sulfuric acid reacts with 1 mole of barium hydroxide. So that means we have the same number of moles of barium hydroxide as sulfuric acid. And then when we look at finding the concentration, it's moles divided by volume. So we've got the moles, we just found that out. The volume in the question was 18.6 centimeters cubed, which is 0.0186 decimeters cubed. And that gives us a concentration of 0.0269 moles per decimeter cubed. Right, let's crack on with question 2. So this is very similar to the previous one. If you can, have a bash at doing this yourself. So first of all, we're going to work out our moles of sulfuric acid. We've got a concentration of sulfuric acid and a volume. So we times those two together, remembering to convert centimeters cubed into decimeter cubed. We now look at the equation, and 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. So to find the moles of sodium hydroxide, we need to times moles of sulfuric acid by 2. And then it's back to finding out our concentration, which is moles divided by volume. So moles we've just worked out. Volume is going to be 0.025 decimeters cubed, and that gives us a concentration of 0.0752 moles per decimeter cubed. So let's go on to question 3, and we now need to calculate the volume in centimeter cubed of potassium hydroxide required to neutralize 25 centimeters cubed of 0.015 mole per decimeter cubed nitric acid. So we've got a volume and a concentration, so we can find our moles of nitric acid. When we look at the equation, you'll see it's 1 nitric acid to 1 potassium hydroxide, so we have the same number of moles of potassium hydroxide. And then finally, our volume of potassium hydroxide is going to now be moles divided by concentration. Concentration they told us in the question, and if we do that, it's 0.0075 decimeter cubed, times that by 1,000 to give us 7.5 centimeters cubed. So question 4, we prepared a solution of sodium hydroxide, and that has a volume of 250 centimeters cubed. And 25 centimeters cubed of that solution required 28.2 centimeters cubed of 0.1 moles per decimeter cubed nitric acid for neutralization. So we need to calculate the mass of sodium hydroxide that was dissolved to make up that solution. And there's the equation there. So as ever, we've been given a volume and a concentration for HCl, so let's work out the moles. Have a look at the equation, it's 1 to 1. So we have the same number of moles of sodium hydroxide, but remember that was in 25 centimeters cubed. So we need to multiply that by 10 to find how much was in the original 250 centimeters cubed. And then we take that number and times it by the molar mass of sodium hydroxide, which is 40, and that gives us 1.128 grams. So let's look at question 5 now. And we need to find the volume in centimeters cubed that we need of that hydrochloric acid that we need to neutralize 200 grams of calcium carbonate. So we've got a mass now. So if we go back to our first ideas on the moles, that's mass over molar mass to give us the moles of calcium carbonate as being 1.998. Look at the equation, 2 HCl's for 1 calcium carbonate. So I multiply my moles of calcium carbonate by 2 to give me 3.996 moles of HCl are going to be required. And then the volume of HCl is moles divided by concentration, and that gives me 0.799 decimeters cubed, or 799 centimeters cubed.